What if the strangest sound ever recorded wasn't sent by aliens, wasn't a hidden code, and wasn't science fiction, but instead was the actual electrical texture of the space between stars captured by a machine older than most people alive today? And what if the machine that captured it is now dying 1 watt at a time, drifting further from us every single second, with no replacement ever built to take its place? Before we go any deeper into this, if you have ever felt a chill reading about deep space, do me a small favor. Tap that like button right now. Hit subscribe so you do not miss what comes next, and share this with one friend who still believes real science is more interesting than fake headlines. The story begins almost 50 years ago in a clean room at a launch site in Florida, with a spacecraft no one expected to outlive its own 5-year budget. Voyager 2 lifted off from Earth on August 20th, 1977, just over 2 weeks before its twin, Voyager 1. On paper, the mission was modest: fly past Jupiter, swing by Saturn, snap some pictures, collect a few readings, then drift off into the dark once the fuel dried up and the money disappeared. Nobody on the engineering team seriously imagined that the same machine would still be talking to us almost half a century later. And yet, here we are. What changed everything was a coincidence of orbital mechanics so rare that it only lines up once every 176 years. In the late 1970s, the 4 outer planets of our solar system arranged themselves in a chain that let a single spacecraft use the gravity of each giant world to slingshot itself toward the next one. That trick saved years of travel time and an ocean of fuel. Voyager 2 remains the only ship in history to have ridden that exact alignment past Jupiter, Saturn, Uranus, and Neptune in one continuous journey. It reached Jupiter in 1979 and Saturn in 1981. And there, Mission Control made a decision that quietly rewrote the next 40 years of space exploration. Instead of ending the mission as planned, they pointed the spacecraft toward Uranus and Neptune, 2 worlds no probe had ever visited up close, and none has returned to since. The discoveries came fast. At Uranus in 1986, Voyager 2 found 11 previously unknown moons and 2 faint rings that no telescope on Earth had ever picked out clearly. At Neptune in 1989, it photographed a storm roughly the size of Earth tearing through the planet's blue atmosphere, the feature that would later be nicknamed the Great Dark Spot, and confirmed that Neptune, like its larger sibling, wore rings of its own. That Neptune flyby was also the last time the cameras on either Voyager were ever switched on. Once the planetary tour was over, the obvious next move was to shut the whole thing down. Engineers assumed the spacecraft had done its job. Funding for a longer mission did not exist, and the generators were already fading. But instead of turning it off, Mission Control did something almost tender. They pointed both Voyagers outward, toward the very edge of everything the sun controls, and simply kept listening. Before we follow them out there is something bolted to the side of each Voyager that deserves your attention because it quietly shapes the emotional weight of everything that follows. Each spacecraft carries a gold-plated copper phonograph record, a kind of message in a bottle put together by a committee led by the astronomer Carl Sagan and a small group of artists, writers, and scientists. Pressed into that record are greetings recorded in dozens of human languages, the sound of wind and thunder and surf, the calls of whales and birds, around 90 minutes of music from cultures all over the planet, and more than 100 images physically encoded into the grooves, showing things like human anatomy, the structure of DNA, a pregnant woman, a city skyline, and a child eating. The instructions on how to play the record are etched onto the cover itself, in case whatever eventually finds it has never seen a record before. In 1977, the people who made this were not pretending it was science. They were performing an act of hope. A message sealed inside a tiny bottle and thrown into an ocean so enormous that the odds of it ever washing up on any shore are, by every rational measure, close to 0. But it is still out there right now, riding alongside the same aging machine responsible for the strange recording this video is actually about. And that brings us to the moment most viewers have never heard about, the strange moment that headlines keep getting wrong. For most of its journey, Voyager 2 sat comfortably, inside something called the heliosphere, a vast, invisible bubble blown out by the sun. A constant wind of charged particles streams outward in every direction from our star, carving a protective cavity around every planet, moon, asteroid, and comet in the solar system. Inside that bubble, the sun's magnetic field and solar wind dominate everything. Outside it, things change in ways scientists are still trying to map. Voyager 1 was the first to cross that boundary in August 2012 at roughly 121 astronomical units from the sun, which is about 11.3 billion miles. The discovery shocked almost everybody. For decades, researchers had assumed the edge of the sun's influence would be a slow fade, a gentle transition over millions of miles. Instead, the data showed a sharp line crossed in a matter of days. The moment Voyager 1 punched through, the solar wind collapsed. The density of cosmic rays surged, and the direction of the magnetic field around the spacecraft abruptly shifted, as if the sun's grip had simply ended. That left one obvious follow-up question. Was what Voyager 1 experienced just a fluke tied to its particular path through the bubble? Or had both spacecraft, approaching from completely different directions, actually crossed the same kind of real, physical boundary that any ship would eventually hit? The answer could only come from the second spacecraft. On November 5th, 2018, more than 41 years after it had launched, Voyager 2 crossed the line. It hit the heliopause at about 119.7 astronomical units from the Sun, almost exactly where its twin had crossed 6 years earlier, just from a different angle of the bubble. The instant it did, its instruments agreed with Voyager 1 in eerie, almost identical detail. In November 2019, 5 separate scientific papers analyzing that crossing were published together in the journal Nature Astronomy. Each one focused on a different instrument still functioning aboard the aging probe. Together, they form the most detailed picture we have ever drawn of the true edge of our solar system. And one of those instruments is the reason this story sounds the way it sounds. It is called the plasma wave subsystem. Its job is to detect oscillations in the ionized gas, or plasma, surrounding the spacecraft. And here is the part that confuses almost everyone the first time they hear it. There is no sound in space. Space is a vacuum, with no air, no medium for sound waves the way we experience them on Earth. What the plasma wave subsystem actually measures is electrons vibrating back and forth in the plasma around the spacecraft, generating a kind of electrostatic wave. That is a fundamentally different physical phenomenon from the air pressure waves our ears interpret as sound. But by sheer cosmic coincidence, the frequency of those oscillations happens to fall into a range the human ear can process, roughly a few hundred to a few thousand hertz, which means that if you take the raw electron data, run it through a simple mathematical conversion, and feed it into a normal speaker, you can actually hear it. Not a metaphor, a real audible signal. The physicist who led the plasma wave investigation on both Voyager spacecraft, Don Gurnett at the University of Iowa, described the first time Voyager 1's version was played publicly at a NASA press event in 2013 as the moment humanity first recorded sounds occurring in interstellar space. While Voyager 1 was still inside the heliosphere, the tones sat low and steady, around 300 hertz, matching the thin, hot plasma of the solar wind. The instant it crossed into interstellar space, the pitch jumped sharply higher, jumping into the 2 to 3 kilohertz range, the clear acoustic signature of colder, denser plasma pressing in around the spacecraft. That shift alone was hard scientific evidence of the crossing, independent of anything else the probe measured. When Voyager 2's own plasma wave data finally came back to Earth years later, it told essentially the same story from the opposite side of the solar system. Scientists recorded a jump in electron density by a factor of roughly 20, an almost identical signature, produced by a completely different machine at a completely different location, years apart. That match confirmed beyond reasonable doubt that both spacecraft had crossed the same kind of physical boundary. Gurnett summed it up plainly. The long-held assumption that the solar wind simply fades away gradually the farther you travel from the sun was wrong. There is a real distinct edge out there, sharper than most scientists had expected, something closer to a weather front than a slow transition, crossed in a matter of days rather than the years that earlier models had predicted. There was also a genuine surprise, hidden inside Voyager 2's readings. Where Voyager 1 had found the interstellar plasma just beyond the heliopause slightly denser than predicted, Voyager 2 found it slightly warmer than expected. That hint suggested the bubble surrounding our solar system is being compressed unevenly by the surrounding interstellar material, pushed harder from one side than the other, likely shaped by the sun's own slow movement through the galaxy over millions of years. That is not something anyone could have predicted from a desk on Earth. It only became visible because 2 aging probes, drifting in opposite directions, kept their ears open long after their cameras had gone dark. If you have been watching this far, this is the part of the story where I want to ask you something small. The science behind this video is dense, and I am glad you stayed for it. If this kind of story speaks to you, subscribe and turn on the bell so the next one lands in your feed the moment it goes live. The real story has only just started. Now, how does this translation from data into sound actually work in practice, and why should you trust it? The plasma wave instrument does not create an audio file on its own. It measures the electric field around the spacecraft dozens of times a second and sends that raw numerical data back to Earth as radiotelemetry, the same way every other instrument on board does. Scientists on the ground take those measurements and run them through a straightforward frequency mapping, converting the raw oscillations into a range a human ear can hear, and play them through a normal speaker. Nothing is added, nothing is removed, nothing is reinterpreted. Bill Kurth, a longtime member of the plasma wave team working alongside Gurnett, has explained that turning the data into audible sound is not about spectacle. It is genuinely one of the fastest ways for a trained ear to catch a shift in frequency or pattern that might otherwise take much longer to notice, while staring at a spreadsheet of raw numbers. In other words, the sound is not decoration layered on top of the science. The sound essentially is the science, just rendered in a form a person can actually feel, which means this signal deserves far more trust, not less, than the vague claims that pop up in viral space headlines. The raw measurement, the published density figures, the peer-reviewed papers in Nature Astronomy, the named scientists willing to explain their reasoning on the record, all of it is fully documented and publicly available. Compare that with how a fabricated space story usually spreads. Vague sourcing, unnamed researchers, claims that grow more dramatic the further they travel from the original data. In this case, the true version of the story is arguably stranger and more affecting than any invented transmission ever could be, because it is real, captured by the only objects humanity has ever built that are still out there listening. And that word, still, is exactly where the second half of this story becomes a countdown. Voyager 2 runs on a radioisotope thermoelectric generator, which is exactly where the second half of this story becomes a countdown. Voyager 2 runs on a radioisotope thermoelectric generator, which is at heart a block of decaying plutonium turning heat directly into electricity. It was never designed to last forever. Every single year, that power source loses roughly 4 watts of output. For more than a decade now, mission engineers have had to make increasingly painful decisions about what to sacrifice to keep the rest of the spacecraft alive and able to phone home. The cameras were the first casualty, switched off permanently right after the Neptune flyby in 1989 because there was nothing left to photograph and no spare power to waste on them anyway. Since then, it has been a long, quiet triage. One system after another has followed. Heaters, backup circuits, anything that was not absolutely essential to keeping the surviving science instruments running and the spacecraft able to talk to Earth. Voyager 2's plasma science instrument was switched off in late September 2024. Its low-energy charged particle instrument was switched off in March 2025. Voyager 1's cosmic ray subsystem was shut down in February 2025 to conserve its fading power and its low-energy charged. Particle experiment was switched off in April 2026. For a while, it looked like Voyager 2 was about to be reduced to a bare handful of active instruments. And then, in 2026, NASA announced a workaround engineers have been informally calling the Big Bang Fix, a coordinated power system swap that found extra reserve power and kept Voyager 2's 3 remaining interstellar instruments running longer than the original timeline had allowed. As of right now, Voyager 2 is still operating those 3 instruments, still drifting outward at roughly 34,000 miles per hour, still the only active spacecraft sampling this exact region of space. There is currently no funded, launched, or officially approved replacement mission waiting in the wings to take over if it finally goes dark. The network that catches Voyager 2's faint signal deserves just as much credit in this story as the spacecraft itself. NASA's Deep Space Network is made up of 3 enormous dish complexes spread roughly evenly around the globe in California, Spain, and Australia, positioned so that as the Earth spins, at least one of them is always pointed in the direction Voyager 2 happens to be transmitting from. Some of these dishes stretch more than 200 feet across, built specifically to catch signals measured in fractions of a billionth of a watt by the time they arrive, weaker than the power needed to run a digital wristwatch. Every piece of data this story is built on had to survive that entire journey. More than 21 billion kilometers of empty space, a signal so faint it borders on theoretical, caught by a purpose-built dish, amplified by equipment cooled close to absolute zero to strip out background noise, and only then decoded into usable numbers before a single scientist ever looked at it. Most of the original 10 science instruments each spacecraft carried at launch were shut down decades ago, once their specific planetary targets were behind them, and there was nothing left for them to usefully measure. What remains active now is a small, carefully chosen set, built specifically for interstellar work. Instruments measuring magnetic fields, cosmic rays, and the very plasma readings responsible for that strange recording. Engineers have been forced into an ongoing triage, ranking each surviving instrument by scientific value against the tiny sliver of power it costs to keep running, then switching off, whichever one ranks lowest whenever the generators drop below the next critical threshold. The stated goal from the mission team is to keep at least one instrument alive on each Voyager deep into the 2030s. Squeezing every last watt out of a power source that was never built to still be running almost half a century after launch. Voyager project scientist Linda Spilker has been unusually direct about what all of this means day to day for the team still listening to these signals. She has pointed out that the Voyagers are exploring a region no spacecraft has ever gone before, which also means that quite literally any single day could be their last. But she has also pointed out the flip side of that same uncertainty. That same day could just as easily bring another interstellar discovery. Because not one scientist on this mission actually knows what these instruments might still pick up before the power runs dry for good. To put the actual distance in perspective, Voyager 1 is expected to reach a genuine milestone in November 2026. It will become the first human-made object ever to sit one full light day away from Earth, a distance of just over 16 billion miles. That means a signal from the spacecraft will take a full 24 hours just to travel between it and home, even moving at the literal speed limit of the universe. No human-made object had ever reached that mark before. Voyager 2, a little closer at roughly 13 billion miles out after taking the longer route past the outer planets, is not far behind on that same trajectory. Every single command sent up to either spacecraft and every scrap of data sent back down is now one of the longest round trips any human signal has ever made, stretched out over the better part of a day each way, using an antenna smaller than a kitchen table, aimed with pinpoint precision across a gap that keeps growing every single second. Right now, a signal from Voyager 2 takes roughly 19.5 hours just to reach Earth at the speed of light. NASA's current projection is that the plutonium generators on both spacecraft will likely fail sometime in the early 2030s, though the agency has been careful to note that estimate could shift, because these two machines have already blown past every original prediction anyone ever made about them by decades. When that day finally arrives, there will not be some dramatic final transmission, no last message decoded in a control room somewhere. The signal will simply weaken past the point where even the most sensitive dishes on Earth can pull it out of the background noise. And then, for the first time since 1977, Voyager 2 will go permanently silent. It will continue to drift through the galaxy on its own, still carrying its golden record of Earth's sounds and images, but to know, one, for longer than our own sun has left to live. And that is the real story, hiding under a headline that promises some terrifying decoded transmission from deep space. There is no hidden code buried in Voyager 2's data. Nothing NASA has released was ever kept secret and then suddenly cracked open. What's actually true is stranger and more affecting than any fabricated version. A machine built before most people watching this video were born is still out there right now, past the edge of everything. The sun touches, sending back the literal electrical hum of the space between stars on a dying battery, with a small team of scientists on Earth checking every faint signal that arrives, fully aware that any one of them could be among the last things this spacecraft ever tells us. If this story moved you, this is your moment. Drop a comment below with what surprised you most. Share this with someone who still thinks space is boring. And tap that subscribe button so we can keep telling the real version of stories like this. The next one might haunt you even more. Even once both spacecraft eventually go quiet, this is not necessarily where interstellar exploration ends. NASA and researchers at the Johns Hopkins Applied Physics Laboratory have spent years studying a proposed follow-up mission, sometimes called the Interstellar Probe, designed from the ground up to do everything Voyager 2 did almost by accident, but this time on purpose, with far more capable instruments. Where Voyager 2 stumbled into its historic crossing using 1970s-era instruments, originally meant for flying past planets, a purpose-built interstellar mission could carry dedicated plasma, magnetic field, and particle detectors, engineered specifically to map the edge of the heliosphere in far greater detail, potentially reaching interstellar space faster and studying it for much longer before its own power eventually runs out as well. Nothing has launched yet, and funding and timelines remain genuinely uncertain. But the fact that serious engineering studies already exist at all is a direct result of what Voyager 1 and Voyager 2 proved was even possible in the first place. Before 1977, nobody knew for certain that the edge of the heliosphere was a real definable boundary you could design a mission around. Now there's an entire body of published research, 5 papers deep just from Voyager 2's crossing alone, that any future interstellar mission gets to build on. It's worth pausing on why stories like this so often get twisted into something they are not, because the pattern repeats with real space missions constantly. Genuine findings tend to arrive, hedged, incremental, and attached to a named scientist willing to explain exactly what was and was not actually measured. Manufactured versions strip all of that away and replace careful language with false certainty, usually backed by a vague, unnamed source. Whether it's a supernova that has not happened yet, an old spacecraft image reinterpreted decades later as an alien signal with no published research behind it, or in this case, a plasma wave recording rebranded as a terrifying decoded transmission, implying something was hidden and then cracked open. The pattern is the same. In every case, the real story, once you actually track down what scientists published, ends up stranger and more interesting than the exaggerated version, not less. It just asks you to sit with a little more uncertainty than a viral headline usually allows. Both Voyagers will keep drifting long after their power finally fails and their instruments go dark. Free from any further course corrections, both spacecraft will simply continue on their current paths, orbiting the center of the Milky Way for an estimated 5 billion years or more, essentially outlasting the Sun itself and the solar system that built them. Researchers involved in the mission have estimated that the odds of either spacecraft ever colliding with anything else out there are close to zero across a span of time that makes all of recorded human history look like a rounding error. And that is where the golden record, bolted to the outside of each spacecraft since before most of us were even born, finally becomes the heart of everything else in this story. Once Voyager 2's instruments go silent for good, likely sometime in the early 2030s if current power projections hold, the spacecraft itself does not stop existing. It simply stops talking. It keeps moving, carrying that gold-plated record of Earth's music, languages, and images outward at roughly 35,000 miles an hour. Long after every person who worked on this mission and everyone watching this right now is gone. There is no planned destination, no target star waiting for it. It will simply keep drifting through the genuinely empty space between star systems for longer than human civilization has existed, carrying a message that will almost certainly never be found by anyone. And yet, right now, today, it is still out there, attached to a machine that has spent the last several decades quietly recording the real physical texture of interstellar space and sending it back to us for as long as we can keep listening. That is the part of this story that deserves to stick with you more than any invented transmission ever could. We built something almost 50 years ago that has already outlived most of the engineers who designed it, that is still teaching us new physics about the true edge of our solar system. That is still audibly humming with the genuine sound of interstellar plasma. And that is now counting down, watt by watt, toward a silence that will be permanent. Every signal it sends from here forward is genuinely closer to being its last than the one that came before it. Mission scientists are not exaggerating when they say that. They mean it literally every single day. So the next time you see a headline promising some terrifying, decoded message from deep space, remember what the real version of that story actually sounds like. Not a warning, not a hidden code, just the true electrical hum of interstellar plasma, captured by a machine humanity built decades ago and mostly forgot, could still be out there listening, right up until the exact moment its power finally, permanently, quietly runs out.